Alright, we have another example of solving an equation with polynomial denominators. This one looks pretty easy though. Step 1, we're going to put non-fractions over 1, so this 1 is going to become 1 over 1. Now we have 1 over 1 minus x equals 1 over 1 minus x over x minus 1. Remember the steps. Next step, that's to factor. However, this one is, well, actually, this is a good point. Okay. I remember when I first saw this is one of the weirdest things I'd ever seen. So, and it took me a while to digest. So, you know, this doesn't over here. Well, first of all, notice that these two look almost exactly the same. This one's 1 minus x, this one's x minus 1. As it turns out, you can make them the same by pulling out a negative 1 on the left. So, even though the first term isn't negative, if I pull out a negative 1, that will make this negative 1, and that will make it positive x. In other words, it'll change the sign of what's left. Okay? So that's what I'm going to do. So when I pull out a negative 1, notice if I re-multiply that in, I would get what? 1 minus x, which is what I started out with. Okay? Now that I do that, I can actually flip this, put the x first and the minus 1 next, so it's going to be x minus 1. Still have the negative 1 out front. And, you know, now, this is x minus 1 and this x is minus 1, right? The reason I did that is because it's going to make the LCM much, much simpler, right? So keep that in mind when you have two factors, that one's x minus 1 and the other's 1 minus x. You can factor that to make it a simpler LCM. Okay, so my LCM is going to be negative 1, right? This right here, sorry. And then x minus 1. Okay, again, you don't need the 1. I don't even know why I did that the first time. So just be negative 1 x minus 1 for my LCM. Okay, so that means every fraction bottom needs to have a negative 1 and an x minus 1. And there's other ways to solve this, by the way. This is just one way of doing it. Now the first fraction already has a negative 1 and x minus 1, so I don't have to do anything. Again, you really don't have to multiply by 1 over 1. The middle fraction, now, let's go back and see what we had here. The middle fraction is just 1, so we have to multiply it by both x, negative 1 and x minus 1. The right fraction doesn't have a negative 1, so we will have to multiply it by negative 1 over negative 1. Alright, so again, you know, step 4, I think I simplified that before, is to turn the denominators into LCM. Okay, which is exactly what we're doing here. And again, the right, you need to multiply by negative 1. You don't have to multiply by 1. So now that all the denominators are the same, I can just set the numerators equal to each other, which is what we're going to do in the next step. So we can cross the denominator out and set the numerators equal to each other. Okay. So I think I called this step before something like setting numerators equal to each other, or you can just say combine numerators. In other words, just delete the denominator and whatever you have on top is what you have. And you know, they're combining them just because this minus, you know, you're subtracting this term, and here, over here you just have two single terms, so it's not that big of a deal. So you have this for the top. Now notice I didn't do any simplifying, I just deleted the denominators and set the numerators equal to each other. That leads us to the next step. Actually, before we do the next step, you know, when you combine the numerators, you want to simplify. So I'll just do it on this slide, even though it's on the next one. So we have 1 equals. Now this was going to distribute to both of those, so it's going to be negative x plus 1. And same for here, going to be plus x. Okay. So here's the thing. You're going to move this x over, so it's going to be 1 equals negative x plus 1. And the reason I did this example is because you get 1 equals 1. Whenever you get a number equal to itself, the solution is all real numbers. We've done that before when we did systems of equations and some other lessons. Go ahead and underline that. When a number equals itself, the answer is all real numbers. And that's it. You don't have to check for extraneous here because, you know, you get all real numbers. Now you can plug any number you want to into the equation, alright? and it will work. For example, you can plug in 99, and I did that, and I got negative 1 over negative 98 equals negative 1 over 98, which equals. You will, however, have extraneous solution, and the denominator was 1 minus x, so you can see that if you plugged in 1, it wouldn't work. You'd get 0 on the bottom. So I guess technically it's not all real numbers. There is one extraneous solution, and that's when x equals 1. Otherwise, everything else works for this example. And this is step 7. I ended up combining 2 steps, so that's why it ended up that way. That's it for this example, and for right now, that's it for this lesson. And that's the final answer to this example. If you have any other questions about solving rational equations with polynomial denominators, let me know.